the previous section, you learned how the first and second derivatives can be used to find the maximum and minimum points of a given curve. Let us now apply this knowledge to determine the greatest or smallest value of a variable in a practical problem. It's the same way. It's the same way. If it goes like that, then this is still a minimum point. If it goes like that, it's still a maximum point. Do you understand? Okay? And you can also use the second derivative test. It's perfectly fine. Okay, now let's take a look at the box from page 59. For the function fx, if dy dx is 0 at x equals to a, then there is a stationary point at x equals to a, and fa is the stationary value of y. It's the same thing. If dy dx is 0, it's a stationary point. Okay, next, part B. If dy dx is 0 and d2y dx squared is less than 0, then it's a maximum point or maximum value at y. Understand? Same thing, Part C, if dy dx is 0 and d2y dx squared is more than 0, that is a minimum point and fa is a minimum value of y. Okay? Understand? Okay, I will show you with examples. Okay, it's exactly the same. Let's look at example 6 first. Now, I usually do not like to use the visualizer because I will go very fast. When I use here, you are better because you can see how I work. Is that clear? Okay, now let's take a look at the first example. Example 6. Two positive values, x and y, vary in such a way. xy is 48. You must note, the question says x and y are what values? Positive. Okay. Now, another value z is defined by 3x plus y. Show that z is this. Now, can you see that the first part, the y is gone? That means you are replacing y with x, right? Everybody clear? That's what they are telling you. Okay. Let's call this equation 1, equation 2. From 1, y is 48 over x, right? Everybody okay? So, substitute 3 into 2. We will have z equals to 3x plus 48 over x, correct? Alright? But I still do not get the one that is over there. Now, can you see I can factorize out 3? Then I get x, right? Factorize out 3, I get 16 over x. Can you see what I'm talking about here? So, therefore, this is shown. Everybody okay? Everybody okay? I take out common factor of 3. Alright, next part. This is the part where students don't know how to do the maxima and minima. Now, plus, you can see, even if you don't know part 2, right? Part 1 you do like that, you write in terms of y, after that you sub in points. Everybody clear? So all these marks must get. Alright? Now part 2. Calculate the value of x for which z has a stationary point and show that this value of x makes z a minimum. Okay. That means I must do dz dx. Alright, I must do dz dx. Okay. Now, do you all agree that if I differentiate, this one is easier, then I put a product. I always don't like the product, but can you please rewrite this as like that? Easier for you to differentiate. Am I right to say that? Yes or no? Okay, if I differentiate this, what do I get? 3 minus 48x minus 2, right? Can you see it? Okay, so I will have a 3 minus 48 over x squared. Am I right? Everybody okay? 3 minus 48 over x squared. Alright? Now, so when dz dx is 0, I will have. Alright. Okay, so I will have. Alright. I will reject one of them. Why? They want positive, right? So negative, reject. So x will just be equal to 4. Right? You see that? X will just be equal to 4. Now look at the question again. What did they say? Calculate the value of x for which z has a stationary value. That means at x equals to 4, it has a stationary value because z dx is 0. Everybody clear? But I still got a second part. Look at the question again. At and show that this value of x makes z a minimum. You can either use first derivative or second derivative. Okay? But look at z dx. This one, if I want to find d2z dx squared, is easier, right? Can you see what I'm talking about? When I differentiate this, what is this? 0. What is this? 96x minus 3, right? So it will be 96 over x cubed, correct? Okay, now, when x is 4, can you see the stationary point is when x is 4? Okay, what is d2y dx squared? Sorry, d2z dx squared? 96 over 4 cubed, right? Now, I don't need to work out, I know this is positive. Can you see this is positive? Now, if this is positive, that means what? Z is what? Minimum, right? Can you see it? Z is minimum when x is 4. Can you see what I'm talking about? Z is minimum when x is 4. Everybody clear? Okay, now, I want to add something to the question. The question just say this, because it's very common. Students after all the way forget it. The question say, show that this value of x makes z a minimum. So can you see that z is a minimum when x is 4? Okay, what if I say find this minimum value of z? That means I must sub in here. Can see how? Can see it? What's the minimum value of z? It will be 3 into 4 plus 16 over 4. Can you see what I'm talking about? So what is this? 3 into 4 plus 4. So 3 times 16. Answer? 48. So the minimum value of z is 48. But this one, they didn't require you to find. Do you understand what I'm saying? They just want you to show that it's minimum only. Hey, jialat. 4 plus 4 plus 48. I'm going to 4 plus 4. Jialat. So what's this? 24. Sorry. Thank you for telling me. Okay, can? Can or not? Understand? Can already? Okay, now. Then there's another trick that the O-level they like to teach you. They will say that, show that the minimum value of what is this. Then must you still prove that it's a minimum? You know what I'm saying? The question of this say minimum, but must you still prove that it's a minimum? Yes. They give 1 mark for that proving. Understand? They don't, if they say show that the maximum value is this, must you still show that it's a maximum? Yes. You must show that the 2y dx squared is 1. Understand what I'm talking about? Because they give 1 mark for that. A lot of people lose the 1 mark because it doesn't show. Everybody clear? Okay, so this is one of the easiest one, number 6. Is it okay? Example 6. Are you okay? Just that this part, this part here, the question did not say, but you can still find it out. Everybody clear? Yes. Okay, now next example. Example 7. All of you now. It's not so simple, This one is the simplest, Life is going to be difficult right now. Are you okay with the first example? Example 6? Okay, good. Now, can we look at example 7? This type, example is even worse. Example 9 is the worst. Okay? Now, let's take a look at this. Let's look at example 7. Find the minimum possible perimeter of a rectangle whose area is 100 cm squared. A lot of you, once you see this, I should really do it. Just know what you're for. Right? Sometimes it's very dangerous to have one liner because you don't know what you're doing. Everybody clear. Okay. Now, let me just do this first. They say find the minimum possible perimeter of a rectangle whose area is 100 cm squared. Now, I let this be length and I let this be breadth. Is it okay? Now, first thing, what must you do? L times B is what? I know it's area, so it's 100. parameter? What is parameter? 2L plus 2B. This is from primary school. Everybody okay? Alright. Then how? You want to find the minimum parameter, right? Find the minimum possible parameter. Minimum value of P, correct? Okay, hold on. This one got two variables, so cannot. I want to change it to one, that's all. Okay. Correct? B is 100 over L, right? Or if you want to follow, it doesn't matter. If I want to follow the textbook, what do I have? L is 100 over B also can. It doesn't matter, correct? So, let's call this number 3. Substitute 3 into 2. What do I get? Agree, class? Okay, I expand out, what do I get? 200 over B plus 2B, right? Correct now, class? Excuse me, I'm talking to you. Yes, huh? Okay, now. Parameter is 200B minus 1 plus 2B, right? Now, class, I want you to take note here. They want to find the minimum parameter. That means they want dp something to be 0, right? Minimum and maximum are stationary values, so they must be 0. So this one I differentiate will be dp db, correct? So what does this give me? Negative 200b minus 2 plus 2, right? So what is this? Negative 200 over b squared plus 2. Agree, class? Yes or no? Now, I haven't said minimum yet. For it to be stationary is when what? dp db is 0, right? Now, I repeat. When dp db is 0 means p is either maximum or minimum. Agree. We have not tested. So, I will have. So, 200 over b squared is 2, correct? So 2b squared is 200. B squared is 100. So b will be plus minus 10, right? But can b be negative 10? Why no? Because what? It's a length. Okay. So negative rejected. Therefore b is 10. Everybody clear? Therefore b is 10. Am I right to say that? Yes or no? Okay. B is 10. Now, next thing. Now repeat. P is stationary. There's a stationary point at B equals to 10. But we do not know whether is it a maximum or a minimum point. Agree? So dp db. dp db is this one. What is d2p db squared? b minus 3. That means it's 400 over b3, right? Okay, so when b is 10, d2p db squared is actually 400 over 10, which is positive, right? Correct. When it is positive means what? When b is 10, p is minimum, right? Everybody okay? Okay, now I repeat first. All of you listen up. First, you find this one. This one doesn't guarantee anything. It just means that it's stationary. That means it's either a maximum or a minimum. Then you go and test. Then it becomes a minimum point. Okay, but this one is what I've been talking about. Look at the question. What did they say? Find the minimum possible parameter of a rectangle whose area is. That means it is minimum when B is 10, right? Alright now. Okay, so minimum parameter. just now we wrote it in terms of B already. So now B is 10. 20 plus 20, what's the answer? 40. So the minimum P is 40 cm. Everybody okay? Everybody okay? Do you understand what I'm saying? Okay, I repeat. When we have this one, it just means stationary. That means can be minimum, can be maximum. Okay, then we go and test it. Then confirm minimum. Then we go and find the minimum. Okay, can? Can? Everybody okay? Alright, now, it's always like that now, but the thing is that this thing change. Okay? There are many types. That's why it's difficult. But the concept is the same. Everybody okay? Alright, next one. Example 8. Now, let's look at example 8. Last time, O levels, right? They give one, like, a net and to fold into how to say, a container. A lot of people die because we don't know what that's thing is. Okay, but actually it's the same. Understand? Okay, alright, now let's look at example 8. Let's look at example 8. Okay, let's get example 8. The diagram shows a piece of paper in the form of an equilateral triangle PQR. Now, first of all, may I know what is an equilateral triangle? All three sides are the same, or all angles are equal to 60 degrees. Okay, now, of side YCM, that means all these are Y. Okay, next. A smaller equilateral triangle of side XCN is cut off from each corner. These three are the same, and it's XXX. Is that understood? This is what the question is talking about. Okay. Now, show that the area of each triangle that is cut up is square root 3/4 x squared cm squared. Okay. I'm just going to pick one small triangle here. We know it's x, right? Now, you know that if I put like that, this one will be 60 degrees, right? Correct now, class. Okay. Now, how would I find the height here? If I know this is 60 degrees, how do I find the height here? The height, right? Opposite over hypo, am I right? H over what? X, correct. So what is H? X sine 60, right? 60 is a special angle. What is sine 60? Root 3 over what? Root 3 over 2? Okay, yeah. 0 3 over 2? Okay. So this will be root 3 over 2x, right? Now, we know this is an equilateral triangle, so it's half area, half times base, which is x. Now, I don't use times, it's quite confusing. Half times base times height. So, it will be root 3/4 x squared cm squared. Sure, can you see? Can you see what I'm talking about here? Yes or no? Yes, huh? Okay, good. Next. Given that the parameter of the remaining shape U, V, W, X, Y, Z is 18 cm, show that the area A cm squared of the same shape is given by this. What are they talking about right now? That means the parameter here, after cut out, is how many cm? 18, right? Question tell you. Okay, you have to show this area is how much, right? Agree, class? Yes or no, class? Okay? Alright, now I want everybody to look at the board. This is the important part. Okay, don't listen also, never mind. Exam don't know your homework. Now, if I have this is root 3 over 4x squared, right? If my whole thing y, can you see that the big triangle is actually by the same logic? Can see it now? I don't have to put again. Repeat, this small one is root 3 over 4x squared. So the big one is also an equilateral triangle, but now it's beside y, no? So it's root 3 over 4y squared. Don't need to do again, can you see? Agree what I'm saying? Can, okay, good. Now let's take a look at the next part. There, what did they say? Part 2. Okay, we can deduce that. Alright? Now, let's take a look now. Do you agree that area of the remaining shape is root 3 over 4 y squared minus 3 times root 3 over 4 x squared? Do you agree? Yes or no? This one give you the big triangle, right? Then I minus out 3 triangles. Can you see? Can you see what we're talking about here? Yes or no? Yes or no? Okay. Now, what is the parameter here? This one is what? X. How long is this side? Y minus what? Minus 2x. How much is here? 1 minus 2x. How much is here? X. X. This one is what? 1 minus 2x, right? Agree or not? The parameter. Everybody okay? Parameter is what? The question tell you. Parameter is what? 18, right? 18. So I will have x plus y minus 2x plus x plus y minus 2x plus x plus y minus 2x must give me 18, right? Everybody clear? Now I'm going to combine all the x together. 1 minus 2 is minus 1, right? Plus 1, 0. 0 minus 2 is minus 2. Plus 1, minus 1, right? Alright, minus 1, minus 2. All together? Do you agree it's minus 3x? So, minus 3x. What about y? 1, 2, 3. Plus 3y equals to 18. Correct? I simplify. This set 1 algebra, right? Now, I don't like this. I want to divide throughout by what? 3. 10. 10. Now, so what is my y? 6 what? 6 plus x. Okay. What do you think I want to do? Look at the question. Can you see that A is whole thing in terms of x? That means I want to replace the y here. Everybody clear? Everybody clear? Okay, so I'm going to replace root 3 over 4 6 plus x minus 3 root 3 over 4 x squared, right? Everybody okay? I'm just replacing. So this one is root 3, 6. Alright now. Oh, it's a square, is it? My mistake. This is a square. So I cannot do it this way. Can you see what I'm talking about? Okay. Right, it's a line. Convert the square. Okay. Now, before I do it, can I do a factorization first? It will be easier. I take out what? Root 3 over 4. Everybody okay? most likely the last question I can do it. So can you please pay attention here? Okay? Okay? Now, what is left behind? I will have 6 minus x squared, right? Minus what? 3x squared, right? Okay, so this will be a root 3 over 4. A squared, 36, plus 2ab plus b squared minus 3x squared. Okay, what did the question say? This will be did I make any mistake? Oh, 36 plus 12x minus 2x squared, right? I factorize out 2. Can you see I factorize out 2? So I will put a 2 root 3 over 4. So I'll have 18 plus 6x minus x squared. Okay, now this one simplify. So it's root 3 over 2, 18 plus 6x minus 6 squared. Can you see what I'm talking about? I've shown already. Can you see? Can you see I've shown already? Can or cannot? Can or cannot? Can. It's very tedious, I know. Okay. Now, next part 3. Let's look at part 3, the last part already. No homework today. No homework today. So please pay attention. Part 3. Hence, find the maximum value of A as x varies, justifying your answer. Now, I'm not going to go through the detail. Okay, but I'm going to tell you what it means here. Yes. Now, A is root 3 over 2, 18 plus 6 plus x squared, right? Okay, plus what? 6x. This is terrible. Got it already? Oh, better check how to. Yeah, I made it already. Can I note the A first? I multiply in first. 9 root 3 plus 3 root 3x, right? Minus 3 over 2x, right? Correct. I do like that easier because I'm very scared I forget. Okay, now, first of all, the A, the x, this is 0, right? What will this give me? 3 root 3, correct? What will this give me? Correct? Yes or no? Yes or no? So, when the A, the x is 0, I will have get x equals to 3, right? Can you see I will get x equals to 3? Okay, now, what did the question say? Look at the question again. Hence, find what? Hence, find what? The minimum value of A as x may be justifying answer. Okay. The 2A, the x squared, I differentiate this again. Becomes just this, right? Correct. If I differentiate this, this is 0, I only get negative root 3, right? Can you see this is confirmed less than 0? Can you see it's confirmed less than 0? So, when x is 3, A is a maximum or minimum? Less than 0, yeah. It's a maximum. Correct now? But what did the question say? Find the maximum value of A as x varies, justify your answer. Now, so when x is 3, A will be 9 root 3 plus 3 root 3 times 3 plus root 3 over 2, 3 squared. 9 root 3 plus 9 root 3 plus 9 over 2 root 3, right? Everybody okay? So if I add, what is this? 18 plus 18 plus 4.5. So sorry, not 18 plus 18, 9 plus 9. 18 plus 4.5. 22.5, right? Is it 22.5? I made a mistake again. I made a mistake. What did I do? minus B. Alright, I mistake here, minus. So 18 minus 4.5. Oh, look at me like you know me. 13.5, right? What's 13.5? 27? 27 over what? Yes. 27 over 2 root 3, right? The maximum area. Correct now? Yes or no, class? Okay, I repeat our last part already. Go and find a dx 0, find the x, then prove that it's maximum, and then sub in, find the maximum value. Is that okay, class? Can or not? Can up? No time already. I will not continue. And tomorrow I will do the last example plus all exercises. Is that clear to everyone? Okay, Raymond, stop the video. All the best for your SS.